So today what we're going to talk about is we're going to talk about solution sets to simultaneous equations. The first opening exercise says, consider the following compound sentence. X plus y is greater than 10 and y is equal to 2x plus 1. They want us to circle all the ordered pairs x, y that are solutions to the inequality x plus y is greater than 10. And all the ordered pairs are below in this chart. Then they want us to underline all the ordered pairs x, y that are also solutions to the equations y is equal to 2x plus 1. So now let's deal with the first one. So we're going to circle all of the ordered pairs x, y that are solutions to this x plus y is greater than 10. So let's just start with this first one, 3, 7. So I'm going to substitute x for 3, y for 7. So I get 3 plus 7 is greater than 10. And 3 plus 7 is equal to 10. So 10 is greater than 10. That's not true. So I'm not going to circle this one. We have 7, 3. So x is going to be 7, y is going to be 3. So I have 7 plus 3 is greater than 10. And 7 plus 3 is 10. So I get 10 is greater than 10. And that's not true. So I'm not going to circle this one. Then I have negative 1. 14, so x is negative 1, y is 14. So I'll have negative 1 plus 14 is greater than 10. Negative 1 plus 14 is 13. So I get 13 is bigger than 10, and that's true. So this is a solution to this inequality, x plus y is greater than 10. Then I look at 0, 1. So x is 0, y is 10, or y is 1. We want to see if that's greater than or equal to 10. So I'll have 0 plus 1 is greater than 10. 0 plus 1 is 1. And I see that that is greater than 10. And 1 is not greater than 10. So that's not a solution. Now we have 12, 25. So I'm going to have 12 plus 25 is greater than 10. 12 plus 25 is 37. And that is greater than 10. So this is a solution. Then we have 5, 11. So I'm going to substitute x in for 5. Y is 11. And I'm going to know if that's greater than 10. 5 plus 11 is 16. And that is greater than 10. So that does work. So I'm going to circle this one. Then we have 0, 12. If we're looking at 0, 12, I'm going to have 0 plus 12 is greater than 10. 0 plus 12 is 12, and I know that that's greater than 10. So it does work. So that is a solution. Then I have 1, 8. So I'm going to have 1 plus 8 is greater than 10. 1 plus 8 is 9, and that is not greater than 10. So that's not a solution to this equation, inequality. We have 12, 0. So I'm going to have 12 plus 0 is greater than 10. 12 plus 0 is 12. Is greater than 10. So 12 is greater than 10. So this would be a solution. So I'm going to circle it. Now we have negative 1, negative 1. So in this case I'm going to have negative 1 plus negative 1 is greater than 10. Negative 1 plus negative 1 is negative 2. And we know that's not greater than 10. Okay. So now we just went through all those ordered pairs to see which one would be a solution to this inequality, x plus y is greater than 10. Now what we want to do is we want to go through the same solutions, or ordered pairs, and see, we want to underline the ordered pairs x, y that are solutions to the equation y is equal to 2x plus 1. So I'm going to do the exact same thing I did here, but now with 2x plus 1. So let's look at this. For 3, 7, y is going to be 7, x is going to be 3. So I'm going to get that 7 is equal to 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. So I get that 7 is equal to 7. And that works. So then I'm going to underline the solution. We have 7, 3. So in this case, x is 7, y is 3. So I'm going to get 3 is equal to 2 times 7 plus 1. 2 times 7 is 14, plus 1 is 15. We know that 3 is not equal to 15. Okay? And then we have negative 1, 14. So I'm going to substitute x in negative 1, y is 14. So I'll get 14 is equal to 2 times negative 1 plus 1. 2 times negative 1 is a negative 2, plus 1 is a negative 1. So we know that 14 is not equal to negative 1. Okay? So I'm not going to underline that solution. Let's go on to the next one, 0, 1. If I look at this, x is 0, y is 1. So I get 1 is equal to 2 times 0 plus 1. In this case, I get 1 is equal to 1, and I know that this one works. So I'm going to underline it. So I have 12, 25 now. So x is 12, y is 25. So I'm going to have 25 is equal to 2 times 12 plus 1. 25 is equal to 2 times 12 is 24, plus 1 is 25. So that one works. So I'm going to underline it. Now we have 5, 11. So x is 5, y is 11. So I'm going to get 11 is equal to 2 times 5 plus 1. 2 times 5 is 10, plus 1 is 11. So we're going to get that 11 is equal to 11, and that works. So I'm going to underline this one. Let's go on to 0, 12. X is 0, y is 12. So I'm going to get 12 is equal to 2 times 0 plus 1. So I get 12 is equal to 2 times 0 is 0, plus 1 is 1. And we know that that's not equal to. So it's not going to work. Let's move on to the next one, 1, 8. So x is 1, y is 8. So we're going to get 8 is equal to 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. And we get 8 is not equal to 3. So that's not a solution to y is equal to 2x plus 1. Now we have 12, 0. If we're looking at this, 12, 0, y is 0, x is 12. So we get 0, 2 times 12 is 24, plus 1 is 25. So that's not going to work. And then this last one, negative 1, negative 1. So x, or y is negative 1, x is negative 1. So I get negative 1 is equal to 2 times negative 1 plus 1. 2 times negative 1 is a negative 2, plus 1 is a negative 1. So I get negative 1 is equal to negative 1. And this one works. So I'm going to underline it. So now if we're looking at this for part B, they want us to list the ordered pairs x, y from above that are solutions to the compound sentence x plus y is greater than 10 and y is equal to 2x plus 1. And remember when we use and, they both have to be true. So let's look at all of our solutions here. We're looking for the solutions that are circled, because that would mean that they were solutions to x plus y is greater than 10. And also underlined, because then if they're underlined, they are solutions to y is equal to 2x plus 1. So looking at this, which ones are the only ones that are underlined and circled are this 12, 25, and we have 5, 11. Okay. So now they want us to sketch the solution set to the inequality x plus y is greater than 10 and the solution set for y is equal to 2x plus 1 on the same set of coordinate axes. And they want to highlight the point that lie in both solution sets. So let's look at this. We have our inequality. So let's start off with x plus y is greater than 10. And if we have this, what we always have to do is we want to solve the inequality for y. So in this case, I'm going to subtract x. So we get y is greater than negative x plus 10. And then we have our other equation, y is equal to 2x plus 1. Okay, So now I solved both of these inequalities for y. So now what I'm going to do is I'm just going to go over to the graph. So I have, in this case, remember we have this inequality. Y is greater than negative 10x plus 10. I'm going to treat that, so I'm going to plug that into my calculator. So it's going to be y1 is equal to negative x plus 10. And we have to remember that when we draw this, we're going to get a dotted line. So if I look at this, if I make my xy chart and I substitute that into my calculator, I'm just going to pick any 2 points. So if I plug this into my calculator, one of the points is going to be 0, 10. The other one is going to be 5, 5. So I'm going to go through and I'm going to plot this point. The first thing that I want to do with my axes is I want to go through and label my axes. So I know that I only go up 0, 5 and 10, 5. So what I'm going to do is I'm just going to go up by 1. So I'd have 1, 2, 3, 4, 5, 6, 7, 8. And I want to at least go up to 10. So 9, 10. So I'm going to go up 1, 2, 3, 4, 5, 6, 8. And I'm going to go down by 1. So I have negative 1, negative 2, negative 3, and do the same thing in x. Go down by 1. Negative 1, negative 2, okay, so now I have my axes. So now if I look at this, if I have my axes, then I'm just going to plot my points. So we have 0, 10, so I'm going to go 0 up to 10. And I'm going to have 5, 5. So 5, 5. And then what I'm going to do is I'm going to take my ruler and I'm going to connect them with a dotted line. So I connect my points and just make a dotted line. And then since it's at y is greater than negative x plus 10, I'm going to shade above. So now I'm going to look at my other solution. So I'm going to have y1 is equal to 2x plus 1. And again, if I substitute this into my calculator, I can get my values. I'm just going to pick any 2 points. So I just picked 0, 1 and 4, 9. So then what I'm going to do is I'm going to plot those points. 0, 1. And then I have 4, 9. So we go over to 4, up to 9. And then what I'm going to do is I'm going to connect those points with a line. So now if I look at my graph, when I'm looking at my graph, they want us to highlight the points that lie in both solution sets. So we know in this, the blue solution set, or for the inequality, it's everything that's above this line. So any points that are in here. We know that any points on this red line are going to be solutions to the equation y is equal to 2x plus 1. So where are the points that are in the solution set for y is greater than negative x plus 10 and y is equal to 2x plus 1? Will it be right on the ones that are on this red line and also above it? So it would be these solutions right here that are on that line. They want us to describe the solution set to x plus y is greater than 10 and y is equal to 2x plus 1. Well, we just said it will be all of the points that lie on the line y is equal to 2x plus 1, but it's the ones that are also above the line y is equal to negative x plus 10. Because this dotted line is that line y is equal to negative x plus 10. So we know that it's going to lie above. So it's all of the solutions that are on this line that are also above this blue line, or above the solution set for negative x plus 10. Okay. So I'm going to move on to the next example. Example 1. They want us to solve the following systems of equations. They want us to solve it graphically, and they also want us to solve it algebraically. So I'm going to first solve this solution set algebraically. So if I'm looking at this, I have y is equal to 2x plus 1. That one is already solved for y. We have x minus y is equal to 7. So we need to solve this one for y. So I'm just going to go up here, and I'm going to solve for y. So if I start with x minus y is equal to 7, and I wanted to solve for this y, I'm going to subtract x, and I'm going to get that negative y is equal to negative x plus 7. And then on both sides, what I'm going to do is to get, if I have negative y and I want to get y, I'm going to divide by negative 1. So on both sides, divide by negative 1, divide by negative 1. So I get y is equal to negative x divided by negative 1 is a positive x. Positive 7 or plus 7 divided by a negative 1 is going to be a minus 7. So I have this original equation, y is equal to 2x plus 1, and now I solve this other one for y. Y is equal to x plus x minus 7. So if we know that y is equal to 2x plus 1, and we know that y is also equal to x minus 7, we can set 2x plus 1 and x minus 7 equal to each other. So I'm going to take 2x plus 1 and set it equal to x minus 7. And then what I'm going to do is I want to solve for x. So if I go through and solve for x, I have to get x on one side. So I'm going to subtract x on both sides. 2x minus x is just an x. So I get x plus 1 is equal to x minus x will cancel. We'll just get a negative 7. Then here I have x plus 1 is equal to negative 7. I'm going to subtract 1, and I get x is equal to negative 8. So now that I found out what x is, I can use either equation. Y is equal to 2x plus 1, or y is equal to negative x, or y is equal to x minus 7. So then if I'm looking at this, I'm just going to choose y is equal to 2x plus 1. So I have y is equal to 2x plus 1. I can substitute this x is equal to negative 8 into this x here. So I get y is equal to 2 times negative 8 plus 1. 2 times negative 8 is a negative 16. So I'll have negative 16 plus 1. So then I'll have that y is equal to negative 15. So now I have my solution. My ordered pair solution is going to be negative 8, negative 15. So my solution is going to be negative 8 for x, negative 15 for y. Okay. So now I'm going to do the same thing, except for I'm going to do it graphically. And when I'm going to do it graphically, I'm going to use my calculator. So if I have my calculator, I'm going to type in my formulas. So I turn it on, go to y equals, type in 2x, we'll clear out this, 2x plus 1 will be my first equation. My second equation is going to be x minus 7. So I have x minus 7. So now I have my two equations in my calculator. So then what I'm going to do is I'm going to go and I'm going to hit zoom, and I'm always going to go down, so zoom is right here, zoom, and then I'm going to go down to 6, zoom, standard. So that will give me a negative 10 to 10 graph. So I would look at this. In this graph, my graphs don't cross. My lines don't cross each other. But they look like they would cross somewhere down here. So what I'm going to do is I'm going to zoom, and I'm going to zoom out. So now that I zoomed out of my graph, I can see that they're going to cross at a certain point. They'll cross around right here. So how do I figure out what that point is? Above trace, there's going to be calc. So it's in blue, so I'm going to hit second, calculate. And then what do I want to calculate? I want to calculate the intersect, or the intersection point of the two lines. They're going to ask for the first curve. You're just going to hit enter. Your second curve, you're going to hit enter. And then they want you to guess what the solution is. You can just hit enter, and it will give you your solution point. So graphically, it's going to say -8, -15. So what I want to do is on my paper, I want to kind of sketch this graph here. So what I'm going to do is I'm going to sketch my first graph. So it'll be about this line about right here. So sketch my graph here. And then I want to sketch my other line, which will be, so let's move this over. Be about there. And then I'm just going to label this point. And when I label this point, I'm going to label it -8, -15. Okay? And that's how you do it graphically in your calculator. Now I'm going to move on to exercise 1. Okay, so exercise 1. It says, solve each system first by graphing and then algebraically. So now what we're going to do is, instead of just using our calculator, we're going to actually graph it and see if we can get the intersection point to be the solution set. So let's first look at this. We have y is equal to 4x minus 1. And we also have y is equal to -1/2 x plus 8. So both of these are already solved for y. So what I'm going to do is I'm going to have y is equal to 4x minus 1. And I'm going to also have y is equal to -1/2 x plus 8. So if I have this, I'm going to go into my calculator. I'm going to type in y, clear out everything that's in there. Y is equal to 4x plus 1. Hit enter. And my second one is going to be, well, I'll just do one at a time. 4x plus 1. I want to get a table of values, so I'm going to go to second table. And this gives me my table of values. So I have x, y. I'm going to pick just any 2 points. So I'll pick 0. This is going to be actually 4x minus 1. So now if I go to my table of values, I'm going to just pick any 2 values. In this case, I'm just going to pick any 2. So 0, -1. And I'm just going to pick 2, 7. Okay. Then I'm going to go back and I'm going to type in the second one so I can get my table of values for my second equation. So now I cleared that one out. I'm going to type this in. But remember, when I'm typing in fractions, I have to put them in parentheses. -1/2 x plus 8. Then I'm going to go to second table, and that gives me my table of values. I'm just going to pick any 2 values, so I'm just going to pick 0, 8, and I'll pick any ones that I want. So I'm going to pick 4, 6. You can pick any other points that you want. I just picked random 2 points that are solutions to the equation. Okay. So now what I want to do is I want to graph this first equation and then graph this second equation. So I'll graph this first one in blue. So the first thing that I want to do on my coordinate plane is I want to label my coordinate plane. So I know that if I look at this, I can go up by ones. So I can go up by ones in the x, and I can go up by ones in the y. So if I just label my axes here, and label my y-axes, label my axis going down, so -1, -2, -3, -4. And I'm going to label my negative x-axis. Okay, so now I have my axes labeled. So I'm going to label one, remember to label my x and label my y. So now looking at this, I'm going to plot this first one, 0, -1. So I go 0, -1. It'll be this point right here. And then I'm going to have 2, 7. So I'm going to go over 2, up 7. So then what I'm going to do is I'm going to connect my points with a line. Then I'm going to graph my second one. So I'm going to graph 0, 8. So 0, 8. And I'm also going to graph 4, 6. So if I go over 4, up 6. And then I'm going to connect my points with a line. And then I have to look and see where do my 2 points intersect. It would be this point right here. So this would be my intersection. So this point right here is going to be my solution. And if we look at that, what is that solution? Well, if we go over 2, up 7, this would be what our point is, 2, 7. So our solution is then going to be 2, 7. Okay. And now what we're going to do, so since we just figured that out graphically, by actually graphing it, now we can do it algebraically. Here we have y is equal to 4x minus 1. And here we have y is equal to -1/2 x plus 8. So in this case, I'm going to take both of them. I'm going to set both of these equal to each other. So 4x minus 1 is going to be equal to -1/2 x plus 8. And then here, what I'm going to do is I'm just going to add 1/2 x to both sides. Add 1/2 x. 4 plus 1/2 x is going to be 4.5x. Minus 1 is equal to, this will cancel, I'll just get 8. So now what I want to do is I want to add 1. Add 1. So I get 4.5x is equal to 9. Then how do I get what x is? I'm going to divide by 4.5. Divide by 4.5 to get that x is equal to 2. So now I have what my x is. Now I have to pick either equation here to substitute in for 2. So I'm just going to pick the first one. Y is equal to 4x minus 1. I'm going to substitute in where I see an x. I'm going to substitute in 2. So I have y is equal to 4 times 2 minus 1. 4 times 2 is 8. So I get y is equal to 8 minus 1. So then I get y is equal to 7. So again, I get my solution as 2, 7. And I got the same solution whether I did it graphically or I did it algebraically. Okay. Alright, so let's go on to the next example. Example B. For example B, we have 2x plus y is equal to 4, and 2x plus 3y is equal to 9. So what I'm going to do with this one is I want to use my calculator. So I want to solve each one of these equations for y first. So let's go through and solve it for y. So I start with 2x plus y is equal to 4. And then what I want to do is I want to solve this for y. So I have to move this 2x to the other side. So I'm going to subtract 2x, subtract 2x. I'm going to get y is equal to negative 2x plus 4. Okay. And then if I look at this, I want to solve my other one. 2x plus 3y is equal to 9. So I have 2x plus 3y is equal to 9. I'm going to solve this for y. So I'm going to subtract 2x on both sides. So I'm going to get 3y is equal to negative 2x plus 9. And then in this case, I'm going to divide by 3. So I'm going to get that y is equal to negative 2x divided by 3 is a negative 2 over 3x. 9 divided by 3 is just a positive 3. So here's my two equations. I'm going to do this one in the calculator. So looking at this, I'm going to first turn on my calculator. Then I'm going to go to the y equals. Anything that's in there, I'm just going to clear it out. I'm going to type in this first equation. So I'm going to type in negative 2x plus 4. And make sure for that negative that you're using the negative key and not this minus key. So you're not using the minus key, you're using the negative key, which is right below the 3. So I hit enter. My second one is negative 2/3 x plus 3. So I'm going to go through and type it in. Remember when I type in this fraction, negative 2 over 3, I want to put it in parentheses. So I'm going to have negative 2 divided by 3 x plus 3. Hit enter. Now I have my two equations in my calculator. I'm going to hit zoom number 6, and it will graph it for me. And here, when I do my zoom 6, so it's a standard window, so it'll be, x will be from negative 10 to 10, y will be negative 10 to 10. So now I look at this. I want to figure out where my intersection point is. So I'm going to do second calculate, and then I'm going to try to find the intersection point. So I want to go down to number 5, or just hit number 5. They want to know which one was my first curve, so I'm on my first curve, I can just hit enter. Then at second curve, I can hit enter again. They want me to guess the intersection point, so I can just hit enter again, and they give it to me. So my intersection point is going to be x, so I'll put it on my graph. So we know that my intersection point is x is equal to negative 0.75, and y is 2.5. So I know graphically, so I'm just going to write graphically, my solution is going to be 0.75, 2.5. Okay? Now let's try to do this algebraically. So over here, I'm just going to do it algebraically. And see if I get the same solution of 0.75, 2.5. So looking at this, I have both of my equations solved for y. So if I'm solving these for y, I can set both equations equal to each other. So let's go through and do that. Once I set them equal to each other, I want to solve for x. But I notice that there's a fraction, negative 2 over 3x. If I wanted to get rid of these fractions, what I would want to do is multiply each term. So each one of these terms, negative 2x, 4, negative 2x, 2 over 3x, and 3. I'm going to multiply them by a common denominator. What's the common denominator with 3 and everything else? Would just be 3. So I'm going to take each piece, and each term, and I'm going to multiply it by 3. So here I have 3 times negative 2x is going to be a negative 6x. 3 times 4 is going to be 12, so it'll be plus 12 is equal to, this 3 will cancel with this 3. I'll just get again negative 2x. 3 times 3 is just going to be 9. So now what I want to do is I want to solve this for x. So I have x's on both sides. I'm going to add 2x. Add 2x. So I get negative 4x plus 12 is equal to positive 9. And then what I want to do is I want to go through and solve this for x. So I'm going to subtract 12, subtract 12. So on this side I'm going to get negative 4x, I'll just go over here, is equal to 9 minus 12 is a negative 3. Then I'm going to divide by negative 4, divide by negative 4. So I get x is equal to positive 3 over 4, which is equal to 0.75, which is what we got for x up here. So now when I have x is equal to 0.75, what I can do is I can substitute it into any of these equations. I'm just going to substitute it into this first equation. So I'm just going to go up here. So I have y is equal to 2x plus 4. And here I'm going to substitute in for x. So I get y is equal to 2 times 0.75 plus 4. So now I look at this. 2 times 0.75 is going to be 1.5. So I have y is equal to 1.5 plus 4. This is a negative 2x. So this would be a negative 1.5 plus 4. Negative 1.5 plus 4 is going to be equal, so y is going to be equal to 2.5. So in both cases, I got my solution as negative 0.75, 2.5. Negative 7.75, 2.5. So I know that my solution then is going to be 0.75, 2.5. Okay. Now let's look at the next one. For C, they want us to solve it first graphically and then do it algebraically. So let's look at this one. I have 3x plus y is equal to 5 and 3x plus y is equal to 8. So if I look at this, I want to do this actually graphically on this graph. So if I look at this, I'm going to have 3x plus y is equal to 5. And then I'll also have 3x plus y is equal to 8. And I want to solve both of these for y. So if I solve this one for y, I'm going to subtract 3x, subtract 3x. So I get y is equal to negative 3x plus 5. Do the same thing over here. Subtract 3x, subtract 3x. So I get y is equal to negative 3x plus 8. So now if I'm looking at this, negative 3x plus 5 and negative 3x plus 8, I'm going to come up with a table of values. So I'm going to come up with just a table of values for this one, a table of values for this one. So to do that, in my calculator, I'm going to type in my formula. So clear out whatever in the y equals. I'm going to type this in, negative 3x plus 5. Go to second table, and I'm going to pick any two values here. So I'm just going to pick 0, 5. And then I just want to scroll to a solution that's farther away. Let's just pick, I don't know, 10, negative 25. Or actually, 5, negative 10. But you can pick any points that you want. Okay, so now I'm going to go back to the y equals. I'm going to type in negative 3x plus 8. Then I'm going to do second table. So now I have my table of values. So I always kind of want to look at 0. So I'm going to start with 0, 8. And I'm just going to pick another one, 6, negative 10. Okay. So now what I'm going to do is I'm going to plot or graph these two graphs. So I know that the highest I go up is negative 10. The lowest I go is negative 10. the highest that I go is 8. So I know that I can just go up by ones. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to go up by ones here too. 3, 4, 5, 6, 7, 8, 9, 10. And I go down by ones, so negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and then negative 10. And I do the same thing in my negative x, so negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, and negative 10. So now that I have my graph, now what I'm going to do is I'm going to go through and actually graph it. So I have negative y is equal to negative 3x plus 5. So I'm going to plot these points, 0, 5. So 0, 5, plot my point, and then I have 5, negative 10. And then what I'm going to do is I'm going to draw my line. So connect my points with a line. Okay, and then I'm going to label this one. This one was y is equal to negative 3x plus 5. And then I'm going to do my other points. So I have 0, 8. So I go 0 up to 8. And then I have 6, negative 10. So what I'm going to do is I'm going to use my ruler. And I'm going to draw my line. So when I drew these lines, you can see that these lines will not cross, ever. They just will keep going on and on and on. Those are called parallel lines. And we can see here that we have negative 3x and negative 3x. This negative 3 is the number before the x is called our slope. Okay? In this case, we have the same slope of negative 3. So if we ever have the same slope, that means that we're going to have no solution. Okay? And now let's go through and do this algebraically. So we have both of these equal to each other. So I have y is equal to negative 3x plus 5, and y is equal to negative 3x plus 8. So I'm going to set negative 3x plus 15 equal to negative 3x plus 8. So I'll get negative 3x plus 5 is equal to negative 3x plus 8. So this is me doing it algebraically. So then I have x's on both sides. I'm going to add 3x, add 3x. The 3x will cancel. I'll just get 5 is equal to 8. And 5 is not equal to 8, and it's not a true statement, so it will be no solution. Okay? So now let's look at exercise, for example, 2. For example 2, now they want you to say, now suppose the system of equations for exercise C was instead a system of inequalities. So we have 3x plus y is greater than or equal to 5. And 3x plus y is less than or equal to 8. They want us to graph the solution set. So what I'm going to do is I'm going to have 3x, so I'll have 3x plus y is greater than or equal to 5. And then I also have 3x plus y is less than or equal to 8. I'm going to solve these both for y. So I'm going to subtract 3x, subtract 3x. So I'm going to get y is greater than or equal to negative 3x plus 5. And I'm going to do the same thing on this side. So we have negative 3x minus 3x. So we get y is less than or equal to negative 3x plus 8. So, looking at this, we have our two equations here, or two inequalities. I'm going to come up with a table of values for this one, a table of values for this one. But we already did this in the last example. So I'm going to use the same table of values. So I'll have 0, 5, and 5, negative 10. And for this one, I'm going to have the same one, 0, 8, and 6, negative 10. But now that we have inequalities, we have to pay attention to, are we going to have a solid line, and are we going to shade above or shade below? So let's look at this first one. I'm just going to do it in 2 different colors. So we have negative 3x plus 5, or y is greater than or equal to negative 3x plus 5, and we have y is less than or equal to negative 3x plus 8. So looking at this, I'm going to first label my axes. So I'm just going to go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here I'm going to go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1, negative 2, negative 3, negative 4, negative 5, 6, negative 7, negative 8, negative 9, and negative 10. And do the same thing going the other way. So I'm going to go down by negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So now I'm going to plot these points, 0, 5. So I'm going to do them in 2 different colors here. So I have 0, 5. So I have 0, go up to 5. Here's my first coordinate. I have 5, negative 10. So I go 5 down to negative 10. Then I'm going to connect my points. And then I'm going to do the same thing for the other one. I'll just do it in a different color. I'll do it in blue. So we have 0, 8. So I go over 0, 8. And I have 6, negative 10. And then what I'm going to do is connect my points with a line. Okay. And now what I'm going to do is I'm going to do my shading. So I know that both of these are going to have a solid line because they both have equality again. But here, let's look at this first one. This red one is the line y is equal to negative 3x plus 5. And this blue line is y is equal to negative 3x plus 8. And here, for this first one in the red, I'm going to shade above. So I'm going to shade above negative 3x plus 5. So I'm just going through and I'm shading above. Okay? Then I'm going to go to my blue one here and I'm going to shade below. So I'm going to go on this blue line, negative 3x plus 8, and I'm going to shade below. And I want to figure out where my solution is. If I look at this, where is it shaded red and shaded blue? It would be right in between these lines, right here. Okay? Alright, so there's the end of example 2. What I want you to do is I'm going to actually have you guys come in tomorrow, and we'll do example 3 and exercise 2 together in class. So this is the end of the notes for problem set 22.